Welcome, ladies and gentlemen, to another fine episode of Altitude. I'm Woody Woodworth. Killer episode for everyone today, a roundtable of sorts. We are going to talk about solving distributed security at scale in cloud, among other things. And to help me with this topic, I have two fantastic guests. One who you know and love from a previous episode, Chris McHenry, who's head of security solutions at Aviatrix. And another guest I'm really glad to have on the show, Toby Foss, who is Director of Network Operations at Informatica. Gentlemen, welcome.
Thank you.
Thanks, Woody. Glad to be back.
Yeah, great.
It's good to be here.
So we have so much to talk about. I'm just trying to think of the right way to kick this off. A good angle of approach is going to be to talk about existing security patterns in cloud, how those are working or not working for businesses, and then start thinking about alternative approaches, right? By this, I mean the traditional lift and shift of data center era firewalls into cloud, into a well-known practice called the virtual DMZ or the security hub, right? Where you put your firewall, your next generation firewall into a hub VNet or VPC, you connect all these application spokes to it, and then you redirect traffic to it. That seems to be the prevailing pattern still. Now, there are a couple of different ways you find that pattern. You can maybe consume it as a PaaS service or even as a cloud native service, but fundamentally the architecture is the same. Toby, talk to me about this lifting and shifting of data center firewalls. Is that something that Informatica has done in the past?
So I actually want to step back and kind of say from a theory point of view, in the old world, back, pre-cloud days, we were used to having so much visibility on our firewalls. We could see exactly what was going in and out. We controlled every entrance or firewall entry point. But when we moved to the cloud, we didn't really think about what the cloud was going to bring us. And all of a sudden, we were without that visibility, without that entry point to and from the cloud. And kind of quickly, the world just became used to it. Hey, we don't need it in the cloud. We don't even want it. But now, in the modern world of security, in the modern world of all these changes, people are starting to say like, oh man, I wish we had that back. So now there's starting to be a bigger push in the industry to say, hey, we need the visibility that we used to take for granted. We need some of that control back. And we can't just use the cloud, everyone gets everywhere model. I kind of look at it like a mall. In the old days, we used to like have a big building and we would control all entrance to and from. But then once you were inside, you could go to every store and do whatever you wanted within that mall. And nowadays, we're starting to say like, no, every store kind of needs their own protection, and we need to understand what's going in and out of every store instead of only who's going in and out of the mall. So that same model falls in the cloud, especially, as we're trying to figure out what exactly is moving in and out of our cloud and understanding who's using what. And as we're going to virtual, we don't have these entry points like we used to. So we need more control and more visibility. Those are the two main drivers that are pushing.
Question for you. So I love what you said there. What was your aha moment when you got to the cloud? Was there an event or something where you're like, man, I can't do this, and I used to be able to do this?
We've had many aha moments. There was no one thing that said, oh my gosh, this is the worst ever, but it was all these little things that compound. We had a performance issue. It's really easy when things work or don't work. You can easily say, hey, it doesn't work because of this issue. But later on, when you're like, oh, I can't really tell you what's happening with that TCP getting delayed or why that database is just a little slower. I don't have the visibility into why every once in a while TLS packets failing, and now those are all compiling up into kind of a bigger picture to say, man, in order for us to keep up with the change in the cloud and the change in security, we really need all of those pieces back. We need to be able to dig in deep when we need it, but we also need that 50,000 foot view when everything's working fine, just to make sure it's still going in the right direction.
So by control and visibility, do you mean visibility of the traffic from one aspect of the network to the other? Because as we know in cloud, after it leaves the interface of the virtual machine, it kind of goes into a magic box. Do you mean visibility and control of the platform itself? Like, I really need to debug this virtual machine or the software within, and I don't see what I'm supposed to see? Or is it all those things?
I was going to say yes to all of those those questions. The problem is that in operating these environments, when we're first building them or first troubleshooting them, we have a certain level of requirements. As they're operating and as they're plugging along day to day, we don't really care too much. But as soon as something breaks, as soon as some customer has some issue, then it's all hands on deck. It's get back and figure this out again. You can't keep the level of degree of monitoring and security that you want to have all the time because you don't have the people to sit there and dig through every packet. But at the same time, you need to rely on kind of that automation model to say, hey, things are okay. You can let these packets go. This is okay.
Yeah, it's interesting over the last, I mean, that's one of the big things that I think next generation firewalls brought to the table almost 20 years ago was that level of application visibility. I was working for Cisco at the time, and Cisco acquired SourceFire, and was listening to a presentation by Marty Roche. And he said that the first thing that they did when they were building Snort was they wanted it to be, visibility tool, right? If you have no shot at stopping something if you don't have the ability to see it in the first place.
Yeah.
But what's interesting is the visibility is beneficial and, for more than just security.
Absolutely. And especially in our cloud, in the DevOps world or the DevSecOps world, that we're slowly, those lines between who is security, who is network, who is application are getting so blurred. They will call us all the time and say, hey, we've got issues with the application. What can you tell us? And I'm like, well, I can tell you that I see traffic, or that's about all I can really see. And so getting some visibility back and then also some control. It's one thing to say, hey, I see packets, but it's another thing to say, hey, I see bad packets, or I see traffic that really shouldn't be here. What is it doing here? Back with the Ukraine, there was a big push to stop all Russia traffic. And so these guys said, hey, just block all IPs in Russia. And in the old days in a firewall, I'd be like, oh yeah, that's easy. But all of a sudden now in a cloud world with thousands of entry points on every single NLB, ALB across all the different CSPs, it's all of a sudden like, this isn't an easy solution. To get some of that control back and say, yeah, we can whitelist IPs, or we can look for traffic of a certain type, that'd be nice to have.
It's amazing to me still, I think the level of exposure that a lot of organizations have. I was reading an article by a cloud financial management firm called Vantage the other day, and they put out a cost report every quarter of what they see in their cloud spend among their customer base. And last quarter, NAT gateways were number 9. And the number 9 service in AWS. And when I see NAT gateway, I think, man, that is a box that has less security than my router at home, essentially, right? It's like,
and you're paying that much.
And you're paying that much for it, right? But it's interesting to me, like, how did that become acceptable? How did that become normal to some extent?
I can give you a personal story of how that became acceptable because I faced it. Gosh, it was probably 10, 12 years ago. I used to go to Amazon. I am tired of giving my customers 50 IP addresses, one for every single server. And they're like, oh, run your own, proxy server and do it that way. And I'm like, yeah, but now I'm going to have to manage 2 or 3 times more servers across all my regions and keep them up to date. And then they said, well, why don't you use our new NAT gateway? And I'm like, oh, this is so much better than giving 50 IPs. That's great. Until later on, when all of a sudden I'm starting to look at, wait a minute, they're charging me for that? Wait a minute, I'm paying per packet for that? And even worse, what do you mean I can't see what's leaving my network? What do you mean I have no idea what's going in and out? It was solve an immediate single problem with fewer IPs being presented to our customers, but it never actually solved, wait a minute, we lost all this visibility and we lost all this control.
I think that's the problem. I think that when we rewind and we look at the initial buyers for cloud and the initial value proposition, one of the biggest pieces was speed.
Yep.
And I think historically on-prem, security has a bad habit of slowing things down. So, you get that typical 10-day change request for firewall policy and all of that kind of stuff. And so when you think about, not to bash the shared security model, because it's really impressive what the CSPs do in terms of a security approach, but there is a delineation in that, right? Where it says, hey, now it's your responsibility. And it's your responsibility to configure the network appropriately. And if you decide to choose speed over security, that's your choice, right? And I think that some of it goes back to, who the initial the initial buyers were, the initial value proposition, was primarily targeted at application owners and developers. And unfortunately, we find ourselves in this situation as those application environments grow and as they become more business critical, that we're lacking visibility, we're lacking control, and to some extent, and this is a part that really concerns me, and I'd love to get your thoughts on this. I talk with customers where there's a level of apathy. Sometimes it says, well, we haven't gotten hacked yet. And it's kind of like, okay.
That yeah, I mean,
Yeah,
not
right.
if, it's when. And I see the apathy, but I also see the helplessness. It's not that they wouldn't do something about it if they could, but there's not a simple solution. There is no click and push or Terraform deployment that makes it easy for you to do some solution. No matter what solution anybody comes up with, you also have to have a clear path to get to it. Just because someone comes out with the new coolest service, if there isn't a way to migrate from what you have today to what you're going to need to get there, that's a big difference. You may know that you need to get to the top of that mountain, but if there's no clear path to that mountain, it may just be too far. You may not be able to do it. So part of the problem with all new services, you have to have a clear implementation plan and a way to get there. And that's the trick in today's world. Everything's around automation, whether it's a Terraform script or cookbooks or whatever, but you have to have a clear model that says, put this piece here and do this from now on. And those developers, like you were talking about, that the number one users are not the networking team that's going to implement it, but it's the developers who are deploying it. It's the team that's going to operate it after it's deployed. Those are the ones that really need the help to make sure that these solutions get implemented.
So I definitely hear you on control and visibility. I mean, that's a key pain point. I think, and you would probably agree, there's other headwinds for network infrastructure security people in cloud as well, right? That are fundamentally different than the data center. Chris, you and I have talked a little bit about this before. One is, what's referred to as the endless perimeter. Like you were saying, Toby, the traditional data center model is that shopping mall analogy. I just did a blog where I used an airport analogy, but everything funnels to one nice entry point or checkpoint. You do your trust and verify operation there. You have a pretty firm perimeter. And then once you're inside, you get access to all these services that you want, right? But cloud, from an internet access model, I compared to a teleporter service where there is no perimeter. You just put your code into your transporter, boof, you're at your airplane gate or on the airplane instantly. And so there's literally no opportunity to try to intervene in this unless you artificially introduce a perimeter, right? By way of putting a firewall in there, hoovering or sucking all the traffic into it and so forth. I feel like that's just fundamentally an anti-pattern for cloud, because cloud wasn't ever designed for that. It was designed for NAT gateways, which is click a button, get internet access for a bunch of workloads and be happy. So there's that as well, I think.
So I want to use a similar but different model of immigration in the turn of the century. So, back in the early 1900s, we had places like Ellis Island. All traffic into and out of the United States was funneled through these very specific ports, Ellis Islands, etc., where people were coming into. And then all of a sudden, by the 60s, they had the concept of international travel. Now, all of a sudden, you have thousands of entry points in the United States. Not only those original ports of entry from ships, but you also have train entries and airplanes all coming in for international travel. And now, all of a sudden, Denver, smack dab in the middle of the United States, all has to worry about immigration. And so that concept of anybody can appear at any place in the country and you can't just protect your outside border, you now have to pay attention to all of them. And maybe the teleporting model is even better, because you could, in theory, pop up in a field in the middle of Nebraska just as easily as an airport in Denver. The system wasn't built for that. The system was to funnel everybody through simple front entries. And now we have to protect all of those, and we have to be monitoring for all of those. Someone pops up in that cornfield or in Denver, you need to put just as many protections on them as you would in the traditional coming through city ports and from ships.
I think that's a fascinating example, because to some extent it's a complete change. Technology drove a complete change. There had to be innovation in order to regain control around that change. The outcome was the same. We need to check people. We need to understand who they are. We need to be able to block, known bad guys from coming into the country, but it had to function in a fundamentally different way, right? I'm almost reinventing itself to some extent to evolve for the changing landscape. I don't feel like network security has really done that, specifically for the application space and to some extent for the cloud space. I mean, when we look at the options out there today, it's, you know, the same software that we had 20 years ago, or potentially even the same architecture, like trying to regain control, build these like virtual choke points to some extent, right? And I feel like that is ultimately, to some extent, doomed to fail, because the fundamental change in the technology that is cloud is going to be constantly fighting against that.
And the people that are designing that have to fundamentally change. You can't just say, I'll put bigger, thicker walls on the entry points. I need to put better security on the airports, because you actually have to change about the way we approach security. We have to approach the way we're collecting data and we're centralizing data and we're managing all those airports across the United States. And I don't mean to use just that model, but the truth is that in a data-driven world, that visibility to data across all those points changes the model significantly. You can't just control just a few ports. You have to control all of them equally, and you have to understand what's happening in all ports of entry equally.
Yeah, and when you get to that point, right? I mean, it's a different management model as well, right? I mean, you almost have to, you obviously have all these different points, but you have to have some sort of centralized mechanism for access control, for management of this. It's almost like now you've got this virtual perimeter that's not necessarily as physical in nature. It fundamentally changes the way that you manage and understand and observe and all of those things.
So then the problem becomes twofold. It becomes scalability, because now you have huge amounts of data that you have to be able to sort through and understand, and you need them immediately. You can't wait 3 to 5 days for that data to become available to decide how you're going to deal with it. I know India, as well as others, have set up rules that say you need to notify your customers of a breach within 6 hours, I think, in some cases. And if you're not even collecting your data for 3 days and starting to look at it for 5 days, that 6-hour model just doesn't work, or that 72-hour model for GDPR or something, just 36 hours. All of those are going to continue to get shorter, and the amount of data we're going to be collecting is continuing to grow. And those two things together are going to reach a critical point where fundamentally we can't do what we've done.
So we've got control and visibility. We've got endless perimeter. We've got the necessity to be very rapid in our response and to be able to act in lightning fast fashion according to any kind of breach information or incident information that we collect, because really now business is moving in real time. And then there's another problem that I want to, or challenge rather, I would want to kind of bring on the table, which is the fact that IP addresses, which have so long served us as an identifier of an asset in the traditional network, I think are ultimately failing us in cloud, right? The IP address becomes just an arbitrary piece of metadata that is used by the cloud platform or fabric for reachability, for accessibility, but it changes. It's opaque sometimes, meaning you can't really see it because it's locked behind some PaaS or SaaS service, you know, and it's just totally ephemeral and shifting, or it's moving too quickly, or there's massive overlap due to mergers or acquisitions, and you have two big lines of business coming together and the IP addresses aren't unique anymore. You have 10.1.1 over here and 10.1.1 over there, and which one's which.
Or one point there, Woody, intentionally. Right?
Yeah.
We're starting to see organizations where they want these cookie cutter models, and containers are oftentimes driving that, where it says, oh, well, every single container, you know, hey, I've got, you know, 10 times, hundreds of times as many pods as I had beforehand. I'm going to run out of V4 space. And so we see, you know, reusability and essentially natting closer to the workloads. And at that point in time, what in the world is a firewall going to do when it's essentially
That's
the same
my point.
thing?
All the apples are based on IP addresses. It's an untenable model, right? So Toby, you've done some research. You're getting a PhD in cybersecurity and computer science. Isn't that correct?
Yep. I'm in process. I don't want to say I'm there yet, but that's actually one of the topics that I'm looking to research more, is kind of move away from an IP-based routing model and an IP address permissions model, because quite honestly, IP addresses are no longer reliable. You cannot rely that you see an IP address that you know who it is or what it is or who's using it. So they're no longer reliable. And as you said, they're no longer scalable. Back in the old days, I remember a long time ago, we used to do like a /27 to reserve IP addresses because we'll never use more than 5 or 6 IPs in that network. And now we're, of course, getting bitten like, oh, wait, we need a lot more than 5 or 6 IPs in that network. And the only option is add a second network to add more and then combine those two together. And then what do? We go to the opposite. Oh, we're never going to use more than 1,000. So let's give them 16,000 just to be sure. And that model may work now, but in 20 years, maybe not. And maybe 16,000 won't be enough. So those two reasons together have prompted me to do this conceptual idea of maybe we need to go to a different IP address or a different model to deciding what traffic is and how things are allowed to talk. And one of those concepts is an attribute-based routing. So we can say, hey, this is web traffic. Let's give it an IP address that's web. And this is database traffic. Let's never give it an IP address that's database because database should never be out on the web. Or let's say this is security logging traffic. We can give it a different title, an attribute, a tag in the cloud world. And we'll give just the permissions that are necessary for that service at the time that it needs it. Because you may not be using log today, so you don't need the log tag. But someday you want to start tracking that information. And like we talked about, all of a sudden you need to troubleshoot something and you want to start collecting data. You add that attribute, that tag that says, hey, let's start putting this on log, and we'll start collecting that data for logs. And then, hey, we're done with that. We don't need it anymore. Take that attribute away, take that traffic off. And along with that attribute comes permissions. Along with that comes all the added things that you need to do for each one. That's the concept. I'll see if I can actually get something together, but I really think, like you said, IP addresses are a short-lived thing. We had IP4, then we went to IPv6, but even IPv6, while it meets a need, it's still a single way of thinking, and we need something that's more adaptable and changeable. And we're already seeing that in the CSPs and hypervisors doing security-based roles via attributes. So why can't we do more with it? Why can't we do routing? Why can't we do permissions? Why can't we do, all these things that we're starting to expect in the cloud?
2 comments there real quick. First off, V6, great point. I mean, like theoretically, but I would argue that one of the biggest issues with V6 is that you can't, it's like not human readable. Like you
That's
can't
exactly
go in
what I was
there and troubleshoot it. Right?
Yep.
And so like if I'm going in and I'm trying to figure out how, why somebody doesn't have access to something, and I'm trying to look at this massive string of random digits, it's not nearly as usable or understandable as V4 was. But then beyond that, I think this tag and this identity thing is actually something where there's been a decent amount of innovation in the user space, largely driven by COVID, but I think it was happening before then with work from home and BYOD and all of that kind of stuff. I mean, when somebody's sitting in a coffee shop, you can't poke a hole in for the IP address of the coffee shop in order to allow access to something. You have to have something that's, at a higher layer. That being said, I didn't see that happen in the application or what you would say the legacy data center, even the cloud environment, largely because we didn't have good inventory, or what is identity for a workload, because it's not finance, it's not HR, it's what app are you, what data classification do you have, are you subject to GDPR, are you subject to PCI, those kinds of things. And one thing you mentioned that I do think is really interesting in terms of the way that things have shifted is that in the cloud, we actually do have access to a lot of relevant metadata, right? You can query the cloud APIs and you can understand not just tags, but also contextual information, like what role do I play? What region am I in? What account am I a part of? All of those kinds of things can help us make determinations about the identity of a workload that we could use to apply policy.
And those same devices that are demanding those tags, that are relying on those tags, can also identify those tags. Hey, I don't have any web traffic right now. I don't need a web traffic tag. Later on, when I do need to go get an update, I do need a web traffic tag. So I'll use that tag for that short period of time when I need a web tag and I need that permission. No longer are we going to have static entries that say always allow traffic to the internet or always allow traffic to the database, but those rules will be totally dynamic. That whole attribute will come and go as the workload and as the processes change.
Yeah, I completely agree. I think if we're going to approach a solution, and no solution will be perfect because everything's going to grow and change, and the bad guys are always going to have cooler weapons and gear and armor than the good guys. But you can make a really effective stab at it with a platform that's like 90% there. Whatever solution we choose has got to be distributed. It has to have good central policy, right? And it has to be dynamic. It has to understand these assets and be able to locate them in space and time by querying the cloud fabric, because it needs to be able to act on the policy it's been given and actually institute some secure behavior, like block that or alarm on that or allow that or whatever. And so there's two approaches here, right? One is to go agent-based, just put an agent in everything, let the agent be smart. The other is to let the network be smart. So forego agents and the heavy lifting about plumbing little intelligence everywhere in the endpoints, but let the transport mechanism, the network, become intelligent, which is enticing insofar as in cloud, the network is just software. So very little is holding it back fundamentally from being able to become intelligent and being the agency, or rather that, being the agent itself, that thing that acts according to the central policy, right? But I think sucking traffic into virtual machines to protect them it's untenable. It's just never going to work.
Two other comments that I think are cool about an attribute-based model is, one of them is we can start monitoring and say, wait a minute, why is this guy accessing the internet and the database at the same time? So now from a security point of view, you have these added visibilities to say, this guy has a database tag and he has an internet tag. That's the traffic we need to focus on. The guy that has just the database tag, maybe we don't need to focus on that as much, because that's expected traffic from these servers. But now all of a sudden we're having more and more traffic, and we're having to go through more and more layers of decryption and understanding to get to the same thing that we could simply do with identified tags that we're using in a cloud model anyway. Anybody that's gone through cost exercises trying to understand how much we're spending on a certain service or how much we're spending on types of traffic, I can't tell you how many tags we put in place on services so that we just know who's spending the money or what service is using it. Why don't we use that same identifier and that same traffic to also understand what they're allowed to do?
That's a great point. Yeah, you nailed it. It's funny, that's the incentive is there, because cost is always an incentive.
Yeah.
When there wasn't a real cost driver, nobody maintained their CMDBs. Now you got to have those tags so that you can charge something back or understand why you're paying so much money. And so consequently, as a side benefit of that, we have decent identity, which is a great foundation. Now we just need to figure out how we can leverage that to do security or to do enhanced visibility.
The second point I wanted to bring up, Woody, specifically to your point, was the agent versus agentless model. We have many services running in our environment, and many of them have agents. And the idea is to have our servers do the work we want to pay for, and not all these agents to monitor the work we want to pay for. So I'm just coming up with a theoretical number, but if you had a server that was 0 to 100% and 20% of that was just agents monitoring, you now have to have a server that the work you need it to do is 80% and 20% of it is just monitoring the work you need to do. So you're 1/5 or 1/5 higher in your cost simply because you're doing stuff to monitor what should be there already. So by moving it off into a network-based model, or maybe a dynamic model off of those servers, let those servers do the work they need to do, and you don't need all these agents to decide if they're allowed to do the work. But then back to your point on the network model, imagine as we're getting into this AI model where we can start watching, hey, traffic is not doing what we expect, or people are using it in ways we didn't expect. Maybe we need to change our model. Everybody has this negative opinion on what AI might do, but it also can help us direct what we can do better. If we can direct our traffic and direct our servers to focus on the parts that people want and not so much on the parts that we don't need, it's also a way to drive cost or reduce costs. What I'm trying to say, just as a whole, is we're going to continually move in the idea of offering services efficiently and securely and scalable and available. And as each service keeps expanding. We expand it for a certain business case. We need traffic in AWS and OCI. Oh wait, now we also need Azure. Oh wait, we also need GCP, and we keep changing our goal line or what our metrics are. And then we're like, oh well, now I need a service that works across all four, but they're all four implemented in different ways. And it gets really, really hard to say, hey, we've moved this goal line. Now we've moved this one. Oh, wait, we should move these two. Oh, now we're going to move these. And coming up with a model that continually adapts and grows is going to be the challenge of network professionals and IT and application performance.
I think another really cool thing about attribute-based networking, attribute-based security at scale would be the ability to expose these attributes as primitives as a sort, or some kind of base language that application owners and DevOps people could just consume. They're going to know the types of services and applications they're deploying better than any network people ever would, right? They know that better than I ever will. So then you expose a list of a dozen or more different types of traffic that particular app needs to consume. They're just going to click that box or highlight those key value pairs and say, yep, it's a web app. Yep, it's got database. Yep, it's got logging. Here are the machines that are doing that. And then the network will automatically know how to build itself and adjust itself based on the attribute, right? Oh, it's logging traffic. I'm going to quas it down. Oh, it's web traffic. I'm going to put all the security protocols and TLS inspection I need for web traffic. Oh, it's database. To your point, I'm just going to keep that totally on the down low. Like, I'm not going to expose that anywhere. So it would be really fascinating to even mix AI in on that, right? Where AI can take these tags and it says, okay, I've deployed these same tags in this pattern 1,500 times. I know exactly how to optimize this because the neural network has been trained on these tag types.
Exactly.
So Woody, one of the really interesting parts about that is to do any of that stuff, the network has to be able to enforce that policy everywhere.
Yes.
Because if you're trying to do anything that's attribute-based networking or network security, and you have to think about how to route that traffic through an intelligent device, all of a sudden the developers are not going to be able to help you out, right? And we need it almost so that the entire network is intelligent, the entire network has embedded security, because the irony is, if it's embedded in the network, you actually have to think less about the network when you enforce that policy, or when you author the policy, rather.
I'll add two more parts to that. The other one is by failing secure, if it doesn't have an attribute, don't let it do it. So now the developers have to think about what they need it to do and not just assume it can do everything. I can't tell you the number of times we've had, oh, well, I'm not able to get to the web. Well, why would you get to the web? Well, how do I get updates or patches? Well, you never said you needed updates and patches. So any case that you need to add a new service or a new feature, that becomes a security reviewable event, and we can do an SIA, a security impact analysis, to say, wait a minute, why do you need this server to actually reach the internet? Or why are you asking for this attribute that's never existed before? And we understand it versus just assume that traffic should have been there.
But we can't slow the developers down, right? So
Yeah,
we're getting into this world that's like, oh, back to the 10-day change request, right? But so I think programmability, a lot of the things we've already talked about, where it's integrated into a pipeline, you do some of that security analysis in an automated fashion, potentially analyze the risk of the policy, or even have pre-positioned policy. So as long as the appropriate tag is correct, they don't actually have to have an additional exception. You know, I know that you're an Ubuntu machine, so you're going to get access to updates. That's how it works, right?
But also when the security review comes, they can say this event has never occurred in the past, and all of a sudden it's needing this. What event caused this to happen? And now you're reviewing what changed and why is it needed, versus trying to understand the holistic, bigger picture of what is this server doing and what is it talking to and what could it be used for. You're now looking at why did this event happen and why do we need this additional.
Well, gentlemen, it's a killer, fascinating discussion. I feel like we've just hit the tip of the iceberg. We're going to have to come back once again and reapproach it. Let's give the industry, 6-9 months to evolve and change, and then we can have a touch point and see, how's it going, how it started, how's it going. It's been a really amazing experience to have both of you on the show and to take this topic on. So Toby, Chris, thank you for your time. I feel like this is the beginning, not the end. So
It's a pleasure, guys.
Thanks.
You're welcome. Thank you.